the current x amperes, so x amperes, ampere is the unit of current, at time t seconds after a switch is closed in a particular electric circuit is modeled by the equation this dx over dt. X is the current, t is the time, where k is the constant. Initially, there is a zero current in the circuit. So at t is equals to zero, we have x is equals to zero. X is the current, and it is given in the question that it is the zero current. Now, the question is saying solve the differential equation to find an equation in terms of K for the current in the circuit at time t. And we have to write our answer in form of x is equals to function of time. So I think this is a simple question. We have to solve this differential equation. So how we can solve? See, we can use the variable separable method. If we apply the variable separable method, we can write dx is equals to k minus 3x into dt. Then we can write dx, we can write dx over k minus 3x should be equals to dt. We have applied variable separable method. We have separated x and time variable, t variable to separately. So now we can integrate both sides, right? So do you know the integration of this dx upon k minus 3x? Its integration should be ln k minus 3x and divided by minus 3. Are you getting this, Liana? How I have written this integration? Do you know this is the linear transformation rule? And this should be
Yeah.
your, yeah, the integration of dt should be t, right? If we apply the, see, if we apply the limit here, see, for t is equals to 0, if we take this t is equals to 0, at that time my x was 0. See, here I have to write the limit of x because my variable is dx. So I'm writing the limit for x corresponding to limit of t. For t is equals to 0, my x was 0. Now, for t is equals to t, for any random time t, what should be x? So x should be x in general, I am assuming. So now I have to apply the limit with 0 to x, and this should be 0 to t. So please calculate this. So first you will write, you will put the upper limit. So it should be minus 1 by 3 outside. We should write ln k minus 3x. This, wait, this is the upper limit, right? Minus lower limit. Lower limit should be, or we can write in this way, 1 by minus 1 by 3, we should take it outside completely. And then we should write ln k minus 3x minus. Now we are going to put the lower limit. Should be ln k minus 0. I am not writing this 0. I have written only k is equals to upper limit t minus 0. So we are getting minus 1 over 3. Now we can apply the property of logarithm here. So we should write ln k minus 3x upon k should be equals to t. Now, now we can simplify it. So we should write ln k minus 3x upon k should be equals to minus 3t. See, we have done shifted this 3 to other side, right? So this is the but we have to write our answer in terms of x is equals to ft. It means we have to make x as a subject. So how we can do this? If we take the anti-log, so we can write k minus 3x over k should be equals to e raised to power minus 3t. Are you getting this? Now we can separate them. So it should be 1 minus 3x over k is equals to e raised to power minus 3t. Now you can simplify it. So 1 minus e raised to power minus 3t is equals to 3x upon k. Now shift these things to other hand side. So it will be a over 3 1 minus e raised to power minus 3t. is equals to x. Have you understood it? Please ask any doubt if you have.
So why do you start with um
Sorry, please
why is
repeat.
the upper why is the upper limit t? Where does it say that?
Yeah. Basically, we have to find the function. We have to write our, no, we have to write x in terms of t variable. We have to write a function. So the final t should be anything. The question is not saying find for t equals to 1 second or t equals to 5 seconds like this. The question is saying write in terms of t. So we have taken this as a variable t. So corresponding to that, we have x also as a variable x. We have to write a function. So you have to keep your variable t as a variable, right? Are you getting this?
Okay, yeah. Can I just write this down?
Yeah, yeah.
Also, sir, in the mark scheme, they did it a bit differently. They did
Mhm.
they did t plus c, but I
So,
was wondering why is
yeah.
it plus c on the t side, but then for the dx side there's no plus c.
Okay,
How
okay,
do you
okay.
know which side that's the
Okay, okay, okay. I got your problem. See, basically, see, suppose we are integrating this x. Let us take the simple example. T plus TD. Right? I'm taking a very simple question for your doubt. So what I should write? I should write x squared by 2 plus c, or we can say c1 this side, right? And we have to write here t squared upon 2 plus another constant c2. So overall, can we write in this way x squared upon 2 is equals to t squared upon 2 plus c2 minus c1. Can we shift this c1 to other hand side? And now this c2 minus c1, can we assume this as a new constant? So can we write x squared upon 2 is equals to t squared upon 2 plus c? Can we think in this manner also? So the conclusion, so the concept is if you have integration both side or multiple indefinite integration in a single line, so you don't have to write, you should not write your indefinite constant in each and every integration. It is just a wastage of time. It is just a misusing your ink, the ink of your pen, right? Where we should write the final constant c uh, on any side, either left side or right side, doesn't matter. This constant c will adjust all these things, c2 minus c1, whatever it is going to be it will come and it will give you the correct answer. No problem. Are you getting this concept? You should not write the
Yeah,
integration constant both side each time. If you have, it may be possible that you will have a three or four indefinite integration in a single line. So you don't have to write integration constant for each and every. Just write a simple constant c at the end. Is it okay?
yeah, thank you.
And now for the see. Either you can use your indefinite constant c and then you apply your limit. Otherwise, see what I have done, I have converted my indefinite integration into a definite integration. I have applied my no, limit directly. For t is equals to 0, x equals to 0. For t is equals to t, my x should be x. So I have converted my indefinite integration into definite integration. So that's why I have not used C, that is the integration constant. Still, I think answer will be correct. Is it okay? Answer is correct or not?
Yeah.
Okay. So please try for the second bit now. Given that in the long term, the current in the circuit approaches 7 amperes. Now, if we write this information in mathematical form, if we try to write this information in mathematical form, what we should write for a long term. What does it mean? It means if I take t tends to infinity, if I assume my t tends to infinity, the x should approaches to 7 amperes, isn't it? So we have to find the value of k. Have you understood the meaning of question?
Yeah.
Okay, so for that we have expression x equals to k upon 3, 1 minus e raised to power minus 3t. So now we have to apply the limit. We have to apply the limit as time t tends to infinity. So can you tell me what should be the value, what should be the approximate value if you apply this limit as t tends to infinity? Can you apply this limit and can you tell me what should be the value of x? Should be k over 3, 1 minus e raised to power minus 3 times of infinity. So obviously it should be k over 3, 1 minus e raised to power minus infinity. Can you simplify this? Can you tell me what it should be? Do you know how to find this?
Yeah.
Please tell me what should be this limiting value? This value will be this e raised to power minus infinity corresponds to 0. If you are getting, then okay, otherwise you can ask. So it should be k over k upon 3, 1 minus 0. So it should be equals to k upon 3. And according to question, we have given that this this is the value of x is equals to k upon 3 at t tends to infinity. According to question, this is given as 7 ampere. So what should be k? K should be equals to 21. Is it okay? So the answer should be 21. Any doubt here?
Okay. Thank you.
Please try for the C bit. Should I discuss?
No, I'm doing it.
Okay. Okay. So the question is saying for the C bit, hence find the time in seconds it takes for current to reach 5 amperes. So we have the expression for our current. The current expression was k upon 3, 1 minus e raised to power minus 3t. But but we have the value of k. We have the value of k, right? You have the value of k, so you can you should substitute, you must substitute it. So it should be 21 over 3, 1 minus e raised to power minus 3t. So it means it should be 7 times 1 minus e raised to power minus 3t. This is my
Okay.
x.
So I know where I went wrong. I get it.
Okay, okay, please.
Can we do question 9?
Yes.